Good afternoon, welcome. Choosing Azure SQL Database, you no longer need to be an expert in database performance and security in order to run your databases safely and efficiently. Let the intelligent database do the work for you while you focus on your application-specific needs. Thank you all for joining. Today, hosting this session with me, we have Ron Machoro from Microsoft SQL team, Franz Litzen from CTO of Orbit, and myself, Veljko Vasic. To start this session, I would like to invite Franz to share his vast experience in migrating databases to the cloud, building on top of Azure, and his team's daily challenges. Franz?
Thank you, Veljko. Okay, see if this works. Okay. Hi, my name is Franz Litzen. As Veljko said, I'm the CTO of a company called New Orbit. We are based in the UK. We are a software company and an Azure Gold partner. My job today, just in case you wondered, is to give you guys some context and some real-world experience with the tools that Ron and Veljko are going to talk about. So as a company, just to give you the background, is we build software on Azure for a variety of clients. We've built systems ranging from, on the one end, a fishing app that keeps track of the kind of fish you catch and how you caught them, that kind of thing, all the way up to a very large background checking application for one of the big credit referencing agencies. Yeah, no, not that one that had the issue the other week. The other one. So in addition to that, to the systems we build, we also help other companies move their software to the cloud, to Azure specifically. So as you can probably imagine, we have hundreds of Azure SQL databases running up there, which is why the guys asked me to come and talk to you today. Now some of our systems get very large, thousands of users, lots of data, so performance is a key consideration. We've got to keep them running smoothly. Some of the systems hold very sensitive information, and I don't like to go to jail, and we're also regularly audited, so we've got to make sure that's all, very secure, and we meet all the standards that we have to meet. So I can imagine a lot of you probably have similar kind of issues from time to time. I'll probably use this thing. Before we start talking about where SQL Azure is today, I'd like to just spend a minute going back in time a little bit to just compare where we are today to how it used to be. So we started using SQL Azure back in 2011. And personally, you might tell from the gray hairs, I've been using SQL since it was Sybase. So it's been a while. Now back in 2011, SQL Azure, I don't know, did anybody use SQL Azure back then? That far back? It was pretty opaque back then. You really couldn't see what was going on. If there was a problem, we were completely blind. We just had to guess or ask Microsoft for help. It was secure, no doubt about that, but it really didn't meet any of the compliance standards. So that was a problem. By 2013, we had managed to build quite a few large systems on SQL Azure, and it was getting really tough for us because our clients were pushing back hard. They didn't like that we couldn't tick all these compliance questionnaires. There was no encryption at rest, no TDE, there was no auditing, so that was quite problematic back then. To the point where we started to almost lose business because some of the big companies just weren't allowed to use us anymore. Luckily, today, SQL Azure is completely different. They've been adding features at such a speed I can't keep up sort of half the time. If every time I turn around, there's a new SQL Azure feature. Today, it has almost everything I ever wanted. So that's quite nice. I think it's important to understand that, as I tell my clients, that when we talk about SQL Azure, it's not just like a hosted database, it's not just SQL. It's been fundamentally re-engineered to be a managed database service, okay? For both good and bad. Lots of good, there's some downsides to that as well. But don't think of SQL Azure as a hosted database. It's a lot more than that. All right, so in order to try and make this presentation today real and not just theory, we have chosen one of the systems we have built. We chose this particular one because it's quite typical of the kind of systems we build. It's hopefully should have a lot of the kind of scenarios you guys might be coming across. So we're using that as an example. The demos that Ron and Velko are going to show you are going to be run against a copy of this system. It's a copy. It's not the live one. They're going to abuse it a bit. So Bank BI, just to explain what it is, it's a cloud-based management information system for banks. It's used by banks right across the world. We've got customers in Canada, the US, Africa, all over the world. It's currently deployed in Azure in the US and in the UK. We are deploying to Africa and China in the near future. Okay. Let me just show you a couple of screens from the system if I can figure out how these things work. Right, I've got to press that button there. Just bear with me while I get the tech to work here. Okay. Yeah. There we go. Oh, sorry. Need to unlock that. There we go. Thank you. Okay. So, anybody remember Lehman Brothers? Yeah? Good. Right. So, what a lot of banks have to do these days is they have to comply with a large set of rules called Basel III rules. Quite dull, but one of the things we do is we have all of these dashboards in this bank management information system to tell them whether they're complying with these rules so they can not go bankrupt and that kind of thing. And in this example here, you can see on this particular dashboard is telling us that this particular demo bank is actually not complying. They haven't got enough money to withstand a run on that bank. That's quite useful information to have. We also do things like telling them where they're making their money, where they're not making money, where they're losing money, how money's coming in and out. So we probably have about 100 different dashboards spread across wealth management and credit cards and all sorts of stuff in that system. So quite essential information for a lot of these banks. Okay, and back to that one. Let's see.
Number 5.
5, sorry. You can tell I don't do this for a living, right? Okay. So, yeah, lot of dashboards, lots of reports. They all work directly from SQL. There are good reasons for that, which I won't go into, but that means it puts a lot of strain on our SQL databases. So, where's my pain? 4 things. This causes me 4 types of pain. Number 1, security and compliance. A lot of my systems, like Bank BI, has a lot of sensitive data in it. That means I have to fit in a lot of questionnaires that ask me all sorts of questions about ranging from whether I have TD to whether there's locks on the windows. I also have to deal with the fact that I have a lot of developers and domain experts working on these systems. And, they aren't all security experts. They're also human, well, at least so far. And despite all the safeguards we put in place, sometimes they make mistakes, and I need some backstop to help protect me when that happens. Number 2, performance. Again, not all my developers are SQL experts. In fact, if you hire developers these days, you'll find it's actually quite hard to get developers who are also SQL experts because they don't tend to need to, because they have all of these nice tools that wrap it all for them. So sometimes, they don't test on the full data sets. Sometimes they put new reports straight into production and start killing the performance on the system, that kind of thing. That can happen. Number 3, and quite a recurring theme for me today, systems grow over time. They change. You develop a system, you test it, you get the users to sign off, you deploy it, everybody's happy. 6 months later, 12 months later, it's no longer running how it used to. You no longer have the project team there, everything is slowing down, the users start getting unhappy. That is a really recurring problem. And number 4, in my case, in Bank BI system, every bank has their own separate Azure SQL database, and that's quite a common pattern across my system. So I have a lot of databases to look after. So me, I'm a simple guy. I just want to build software. I want to build it fast. I want to build it at scale. I don't want to be a SQL Server expert. I don't want to hire a SQL Server expert. I can't even just hire them for a month to come in and look at the system because, as I said before, it keeps changing. I need to constantly be looking at these databases, constantly make sure that, that the performance is still okay, that there's hackers coming up with new exploits and trying new ways into systems, and I've got to keep on top of all of that. So that's my pain. Okay, over to you, Velko.
Thank you.
Thank you.
Thank you, friends. Running the Azure SQL Database service, we had an opportunity to talk to a large number of customers. And a lot of them have the same problem as Franz explained. This is a repeating pattern. And actually, while we were developing our service, we had the same problems and same requirements that we had to deal with. Given that we were facing this scale problem almost immediately, we had to invest into knowing what is happening with all of the databases in our service. In order to do that, we built the intelligence that can tell us what is happening and when the things are happening on all of these databases in our service. Today, we are bringing this intelligence to you to use it and benefit from it. One of the great advantages of Intelligent Cloud Database is that it learns horizontally from all of the databases in service, from millions of databases. And this helped us skyrocket our learning potential and helped us develop this intelligence. And gradually, it was able to understand what is happening and detect problems. Today, Intelligent Cloud Database can alert you on issues, threats, and vulnerabilities. And in addition, it can automatically tune itself, making it faster and more secure. In this session, we'll cover two aspects: performance intelligence and security intelligence, and we'll start with performance. More specifically, we'll look into these two features: intelligent insights and automatic tuning. Understanding the database is key for running fast apps and performant applications. And this is not a simple thing. You need to be an expert. You need to understand a lot of weight statistics. You need to understand different columns in your DMVs. But with Intelligent Cloud Database, we are making this much more simpler. Azure SQL Database today continuously monitors your databases, creates a baseline, and compares the current performance with the baseline performance. In case the degradation in performance is detected, intelligent insight is created. This intelligent insight summarizes all of the telemetry that SQL Server has, and it creates a simple explanation of what was detected, containing the root cause analysis and additional details about the issue that was happening on your database. How many of you were in a situation where you had to troubleshoot your app and you're starting from a database and don't know where exactly to start looking for the problem? Well, the next time you should start with intelligent insights. Let me show you why. All right. What I have on my screen here is the solution in Log Analytics for monitoring a fleet of databases. I have a lot of charts here, and all of these charts actually represent different types of telemetry that is available for your Azure SQL Database. As you can see, there are lots of it. Errors, timeouts, blockings, database-based statistics, query-based statistics, and the query runtime statistics from Query Store. As you can see, Azure SQL Database is not a black box. All of this telemetry is available for you to stream it into the Log Analytics or Event Hub and Azure Storage, so you can use this telemetry in any way you want. For example, if you want to stream this telemetry to Azure Storage, you would usually do that in order to archive this data so that you can use it and analyze it afterwards. If you want to integrate this data with your own hot telemetry pipeline, you can stream it to the Event Hub, and from Event Hub, you can move it to any tool you want. Out-of-the-box solution for monitoring Azure SQL Database is provided in Log Analytics, and it's called Azure SQL Analytics. Let me show you how this works. Here, in this solution, I'm monitoring over thousands of databases, more precisely 1,832 databases. All of them are sending telemetry into this solution. And I have a couple of tiles showing me the overall state of my databases. This chart over here shows me the number of errors across all of my databases through time. Selecting this tile, I drill into the errors perspective. And now I can see how many errors are happening per my subscription on all of the databases that belong to these subscriptions. I have the similar view for my servers, so I can easily figure out on which servers I have the most errors happening. Same for elastic pools and for databases as well. I will now want to focus on a single server that is most important to me. I'll select this server over here by clicking on it. Now I see the summary for all of the databases that belong to this server. I can see how many errors are happening on the databases that belong to this elastic pool. I can see how many errors are happening on these specific databases. And on the right side, I can see the specific errors that happened. Selecting it, one of the errors, I will be able to see the timeline and see how these errors happened through time. On the chart here below, I see that there were 2 errors with the error code 208, and I can see how many of them appear through time. I have the similar data set and similar walk through the other types of telemetry available, such as database weight statistics, query store, runtime statistics, blockings, timeouts. But given that this is an intelligent cloud database, it can give you much more. Let me show you. I'll go back now to the home screen of Azure SQL Analytics solution. If we look at this tile over here, called Insights, I can see that currently there are 39 active insights on my databases that I'm monitoring, 56 in verifying, and 218 completed state. Active state means that the issue is ongoing, it's happening, currently happening. Verifying means that the issue was happening, but the system no longer sees the problem. But it wants to wait to build the confidence that the issue is gone. And completed means that the issue is not happening for enough time that the system has built the confidence and said, okay, this issue is now completed. Selecting this tile over here, I get the similar hierarchical report. And now I can see the number of insights generated on my subscriptions, under my servers, elastic pools, and again on the databases. Let's again focus on a single server we want to investigate. I will click on this server, and I drill into it. And now I see only the databases that belong to this server, and a couple of insights that exist there. I will select a single insight, and now I got the Intelligent Insight report. This report has 2 major parts. One is the root cause analysis part that tells me when did this issue start, what was the last update I got regarding this issue, and when the issue was the worst, according to the system. And as you can see here, it has a verbal explanation about the issue that is happening on this DB. It says that critical exceptions are happening, that the database has reached its storage limit, and it has a verbal recommendation on how to try to solve this issue. In addition, Intelligent Insight contains additional details about this issue, and it figured out what are the errors that were happening on this database at the time. Selecting one of the errors, I have the error text on the right, and I have the number of errors through time that were happening on this database. Now maybe this was a simple example, there were a bunch of errors happening, and the system figured out, hey, these errors are happening, so the problem must exist. But let me show you another example. I'm going back to the overview screen of my Azure SQL Analytics solution, and I'm again drilling down into the intelligent insights. I will select the server, and again, I will select one of the insights that is currently active. But before I drill into this insight, I would like you to take a look at the column that says metrics. There are a couple of metrics that Intelligent Insight observes. It observes critical errors, like the one example that we just saw. Critical errors, insights that are tracking the metric of critical errors, appear when your database is facing an error that is causing a workload stoppage. In the example that we saw, the database was hitting its size limit, so it couldn't handle any more inserts, basically meaning that your database cannot handle your workload anymore. Other metrics are duration increase, which basically means that your duration of the queries that the database is executing has increased. In order to do that, Intelligent Insight had to create a baseline of your important and usual queries that are happening, and figure out that comparing the current performance to the baseline, that the current performance has degraded, and your queries take more time now. In addition to these, there are other metrics exist, such as timeout requests percentage increased, and error requests percentage increase. Let's say you have a database that usually has a couple of timeouts. You wouldn't want the Intelligent Insights to constantly notify you that, hey, some timeouts are happening. The same way as with the query duration increase, Intelligent Insights create the baseline, knowing what is expected on your database, and when there is an increase in number of errors or timeouts, the Intelligent Insight is generated, providing you with the root cause analysis about why that problem happened. Going back to our demo, I will select a single insight here, and we can now see the root cause analysis of this insight. Again, we see when it happened, what is the last update, and when the issue was the worst. And in this case, we see that the database is hitting its CPU limits, and we see what was the average consumption at the time. In addition, Intelligent Insight figured out which query was impacted by this problem. Selecting this query, we get the chart on the bottom that says the number of executions of this query. We can see that it increased significantly, but more interestingly, above we can see the duration in seconds of all of these queries executed, and the query text as well. This is a starting point for us to know why the problem is happening with our database. And we now know that the problem appears because the database is hitting its CPU limits. We know which query is impacted and how much. So to summarize, Azure SQL Database continuously monitors your databases. It detects disruptive events that cause poor performance and does the root cause analysis for you. This will help you out, reduce the time to mitigate the problems, reduce the time to detect the problems as well, and it will, in general, help your DevOps team do their work more efficiently. Now, in addition to detecting the issues that are happening on your database, Azure SQL Database recognizes the opportunities for optimization. It can automatically apply them, making your performance of your database and applications improved. If we go back to the example that Franz mentioned, where he has large number of databases that are running somewhat similar, but again, a little bit different workload, tuning each of these databases individually is a hard and tedious task. You need to invest a lot of time to fine-tune hundreds of databases. What is usually done in this situation is that people create the same indexes across all of the hundreds of databases. This does not make the databases run optimally. Some of the customers that France has have one usage pattern, while others have other usage pattern. And for all of these usage patterns, different indexes and different optimizations are needed. To show you automatic tuning in action, we have created a little app that sends requests to our database that has automatic tuning enabled. This meter on the left shows how many requests are happening per second. On the right side, you can see the T-SQL that is actually being executed. It's a simple query. It does the aggregate with some where clause. But what's interesting is that the data in this table is highly skewed. And this means that if you send a query with a certain parameter, a different plan will be used. If the chain of events happen where your cache is cleared in your database, and this query is executed first, SQL Server will cache this plan, and it will use it for all other parameters. This is known as a plan regression. Recently, we have expanded automatic tuning to include the plan regression correction. This option we call force/good plan. Clicking on this button here, regression, exactly that will happen. Cache will be cleared, query with the problematic parameter will be sent, and then the SQL Server will start executing all of the queries that are coming with this problematic plan. As you can see, the number of requests dropped. SQL Server is now figuring out that the problem is happening. It is comparing the previous plan that was used with the plan that regressed, and it forces the previous plan, that was a good plan, to be executed. And as you can see, in a matter of seconds, automatic tuning returned our good plan, and performance is back to normal. This will help you sleep at night, so you don't need to wake up and go fix a simple plan regression. Enabling automatic tuning is very simple. You can do it through Azure Portal, through PowerShell, through the API as well, and you can also do it through the T-SQL. Here is a simple syntax. But to show you how this looks in the portal, I'll go to the Azure portal. I will select the database. I will now select the database features, and I will select the automatic tuning tile. You can set up automatic tuning on the database level, which basically means that you want to set up the general automatic tuning, how you want it to behave. You can inherit settings from your server, making it easy to apply automatic tuning settings across a fleet of databases by configuring it on the server level. You can inherit the Azure defaults, and you can also not inherit any settings for this database. In the part of the screen below, you can see the automatic tuning options that are available, force plan that we just demoed, create missing index, and drop unused or duplicate indexes. As you can see here, you can specify the desired state, and there are three options for the desired state. One is to explicitly enable each of these tuning options, one is to explicitly disable it, and one is to inherit from the database level settings. I will now choose Azure defaults, and I will say inherit force plan and inherit create index, and I want to make sure that drop index is enabled as well. Azure defaults are actually force plan enabled and create index enabled. Applying this, the settings will change. And you can see now, current state of automatic tuning for this database is create index and plan, forcing plan enabled, and drop index enabled as well by the user, by choosing it explicitly. Now to show you what is happening on this database as we enable automatic tuning, I will scroll down a little bit in this menu, and I will choose performance recommendations. In this table tuning history below, we can see several recommendations, and we can see that some of them are in pending state. All of these recommendations are to create or drop an index. Now, not all of these recommendations will be applied immediately. Automatic tuning takes care of your workload. So it will wait, and it will never apply the recommendation while your database is at its peak resource usage. It will wait for the time when your database is not used, not that much used, in order to apply the recommendation. To show you one of the examples, I will go into one of the pending recommendations. For example, this create index. Here you get the information about the index that will be created. Estimated impact, the amount of disk space it will take, and the metadata. What will be the index name, what is the type of the index, schema included, and indexed column, and table name as well. So in addition to not creating indexes while your database is at the peak usage, all of the tuning actions are non-blocking, which basically means that your queries cannot fail because of the tuning action that automatic tuning did. Greatest example is that these indexes are actually behaving differently than the regularly created indexes. This means that these indexes are flagged as auto-created in sysindexes DMV, and the difference in behavior is visible when you try to drop a column on which auto-created index was created. If it was a regular index, this operation will fail. SQL Server will not let you drop the column if it has an index over it. But if it is an auto-created index, this index will move out of the way, making sure that your operation passes. To show you one of the recommendations that is already created, I will select one of them that is in a success state. And here you can see something interesting. There is a validation report for the applied recommendation. You can see the DTU savings across your database. You can see the DTU savings for the affected queries. You can see how many queries were improved, how many of them were regressed, when was the index created, and how much size it took. Below you see the metadata. But a very important point here is that all tuning actions that automatic tuning does are verified after it. As you know, Azure SQL Database has the baseline for your performance. It figures out, hey, this looks like a good optimization opportunity. It applies it automatically, and it starts verifying. It measures the effect of this recommendation. If everything went well and your performance improved, you will get a report like this one, saying, hey, we improved this many queries. This is how your resource usage is reduced. But in case the recommendation was actually not good because of any reason, automatic tuning will figure out that your performance did not benefit from applying this recommendation, and it will automatically revert it, making sure that your performance only improves with automatic tuning. The experience that I showed you is scoped to a single database, but the same experience for configuring automatic tuning and for viewing the recommendation exists on the server level as well. So you can go to your server that has hundreds of databases, and you can see all of the recommendations that exist there. and they're grouped. So if the same index exists, same index recommendation exists on multiple databases, you will see 5 out of 10 of your databases or 100 out of 120 of your databases have this particular index recommendation, making it easy for you to take this recommendation and add it to your source code so the new database that you create have this index immediately. So, Azure SQL Database, in addition to continuously monitoring your databases, also continuously improves your performance. Automatic tuning is very simple to enable. It prevents and mitigates the issues and requires no app changes. Particular tuning operations that are available today are forcing the less good plan, creating a missing index, or dropping the unused or duplicate indexes. This will help you reduce the resource usage of your databases, improve the performance in general, and reduce the query duration, making your overall total cost of ownership lower. The less resources you use, the smaller pricing tier you can pick. I would like now to invite Ron to tell us all about the intelligent security in Azure SQL Database.
Thank you, Veiko. I'm Ron Machoro. I'm part of the SQL security product team. In this part of the session, I would like to show you how you can simply secure your database within minutes and with no need to be an expert in security, using our most advanced security intelligence capabilities, vulnerability assessment, and threat detection. According to the latest Verizon report, which have analyzed over 40,000 security events that were reported during 2016, most of the, no organization and no industry is immune for data breaches. According to this report, most of the events that were reported are coming from external attacker, where almost a quarter of the security events that were reported involve insiders, usually human error or malicious insiders. Since vast majority of sensitive data is stored in databases, securing your database requires your attention. You need to be able to protect against common threats on databases, such as SQL injection, where external attackers are exploiting application code in order to inject malicious queries into your database, or password cracking, usually called dictionary attack or brute force attack, where external attackers are exploiting the use of weak username and password. Credential theft, credential leakage found on the dark market, and privilege abuse, when you have an employee that might exploit his extensive permission for the database. In addition, organizations are required to meet high security requirement recommended by auditing authorities, such as the new GDPR, which is required in order to protect personal information in European countries. We have PCI to protect painful information. HIPAA, again, depends on your business. Unfortunately, most organizations and developers have limited knowledge, time, or method in order to secure their databases. They have lack of abilities to discover sensitive data in the database and ensure that it's protected. They have lack of abilities to identify security holes in their database configuration. And they have lack of abilities to monitor and track suspicious activities going over the databases. The good news is Azure SQL Database provides a very powerful built-in security intelligence features which help you to secure your data and ensure your data is well protected, and if there is potential threats, you will be notified right away. The first security intelligence capability I would like to share with you is vulnerability assessment. This is a new security intelligence capability which was just released for public review this week. It provides you a visibility into your security state and allows you to constantly track and improve your database security state. In short, SQL vulnerability assessment runs a set of security checks. It looks for data in database which is not protected. It looks for security misconfiguration, which makes your database more vulnerable to attacks. And it includes a very useful report for auditing reviews. So if you have audit reviews, you can use vulnerability assessment for that reviews. Now let's talk about a bit more what vulnerability assessment actually checks for. So as I mentioned, it automatically discovers sensitive data in your database and provides you a recommended action how to protect this data using encryption and masking capabilities. In the near future, we plan even to allow you to classify the data and define related auditing policy that will allow you to track access to the sensitive data within the database. In addition, it provides you a set of predefined best practices that allows you to ensure your database is not vulnerable. It's check your firewall set properly to ensure you limit the attack surface on this database. It allows you to check the important security features are enabled, such as auditing, threat detection, encryption. And it's also look for potential users that may have extensive permission for your database and help you to limit the probability of privilege abuse on your database. In case your database has frequent changes, like Fran's case, when you have upload more and more new data on the system and people are changing the database setting, you will be able to set a baseline, which is actually a set of valid security settings that you have verified, which will allow you to ensure and track changes over time. So let's see vulnerability assessment, how it works. For this demo, just a sec. For this demo, I will be using the Bank BI database, the backend database for the Bank BI application that Franz has showed earlier. So as you can see, I navigate to the database blade, and you can see here a new option, vulnerability assessment. A pre-requirement for running a scan, you need to select to configure a storage account from the setting option. So this storage account will contain the scan results. The next step, I will simply click on scan. As I mentioned, this actually triggers a set of security checks that runs against your database. It will take us for a little while. I would like to emphasize that the scan is lightweight and safe, and it doesn't change anything to your application. To your database. It's mainly run a set of query that looks for your database security settings and automatically classify the sensitive data inside. Once the scan is completed, you will be able to see the result. We have a clear summary of the result. You can see that 35 security checks have passed and 4 failed. You can see also the last scan result and a distribution of the security checks that failed. Looking at security issues that were identified, I can see that vulnerability assessment has identified that SQL threat detection is not enabled. It provides me a clear information what threat detection is, and an explanation why should I enable threat detection. But vulnerability assessment does more than that. It provides you a remediation action, which basically simply will open the auditing and threat detection blade, which will allow me to enable threat detection within one click. So I enable threat detection. I also provide an email account that will be used to get a notification and save. In addition, vulnerability assessment has identified that I may have too many users with admin permission. So you can see it's clear, provide me a clear visibility of the list of admin users, of users that belong to the admin role, and it's recommend me that I should review them and consider revoking some of them. As you can see, this is a classic human mistake. People are creating a temp admin for some kind of temporary maintenance or procedure, and they forget to remove it. So vulnerability assessment, in addition for providing me a clear visibility of this set of rules, it's providing me a remediation script. It will automatically open the query editor within one click inside Azure portal, and it will allow me to pick up the admin rules, that the user that I want to remove from admin rules, and I can simply run the query within Azure portal, which will remove this temp account for the admin. In addition, as I mentioned, vulnerability assessment discover automatically classify sensitive data in my database. The Bank BI application is naturally a financial database, which includes a lot of sensitive data. So as you can see, it provides me a clear list of columns which may be sensitive. It's already classifying as financial, and indicate that those columns are not protected. And as other cases, in addition for providing this visibility, it will provide me a clear options how to remediate it. So I can use the encryption capability, the masking capabilities, and RLS. And again, in addition, it's provide me a remediation link, in this case, dynamic data masking, which helps me to limit the exposure of the sensitive data from the application or from admin users that query the data. In addition, I have here a low priority recommendation, which recommend me basically to remove or minimize the amount of users that have select and execute permission. I have reviewed this list, and it seems to be like reasonable for my business application. A lot of companies create few users, some of them for the Power BI, some of them for the application, and some of them for the DBA. And in many cases, it might be valid. So in this case, I will approve it as a baseline, which means this is okay, this is fine by my business. Next time you run a scan, make it success. Now I will run a second scan. After I improve a few of our security holes, again, it takes for a little while. It depends on the database schema. And one of the things that you will see, I'm getting an update report. And as you can see, the threat detection and the last one was moved from the fail to the past. You can also see here a list of all the security checks that have passed. You can also see that some of the security checks I've decided to put as a baseline, which are indicated in the status option. Okay, the second security intelligence feature that I would like to share with you is our threat detection. Threat detection is another powerful built-in capability within Azure SQL Database, which allow you to track and detect unusual and potentially harmful attempts to breach your databases. It's super simple to enable. You simply go to the Azure portal, as you saw in the demo, and once you set it up, you get automatically a set of advanced algorithms that go over your traffic, learn and profile your database activities, and will detect suspicious database activities that are unusual and potentially risky for your database. Once threat detection detects a threat to your database, you will get an immediate email alert according to the email that you have configured, which will provide a clear explanation about the threats and a clear remediation and investigation steps. SQL Threat Detection integrates its alert with our Security Center. Our Security Center is the main dashboard, the central hub for all the security events across Azure. This will allow you to view the active threat on your database on a database level and on a subscription level. I will show it in a minute. So let's see threat detection in action. So again, for this demo, I will be using the same Bank BI application and simulate an interesting attack. So First thing, usually when I do this demo, I'm checking that threat detection is enabled. You already saw me enable this threat detection from vulnerability assessment, which is one of the options. But I want to show you another option that you can ensure that threat detection is enabled. One of the things that we added to the latest release, you have in the database blade an area called database features. And you can basically check if your important security features are enabled. So you can see that France already enabled data encryption for his database, and I enabled threat detection and auditing. You can also see the performance, the auto-tuning that was mentioned. So this is very useful view to see if something is enabled or not. And from these tiles, it's clickable tiles, so you can click on these tiles, and it will take you to the relevant settings. So this is, again, another very comfortable option to see if things are enabled and to enable them. Now for the fun parts. I will now simulate a brute force attack on my database. Again, naturally, brute force attacks is an attempt to log in to your databases using weak username and password. So you can see that this script, again, is just a sample of a brute force attacks. Try to log into my database with the very weak username, SA, password, God. This is a very common users for databases, and it's failed. I already simulated an attack early on, and now I'll get to my inbox. As you can see, I got 4 alerts from my database, which provide me a clear information about what's happening. So you can see that I get an immediate alert. Someone is attempting to brute force my credential. It's provide me clear information about the subscription, the service involved, the database. It's share with me clear information about the source, the IP that was used. And in addition, it's provide me a recommendation, what should I do when I get this alert. In addition, as I told you, you will be able to view your active threats from the Azure portal. So you're going to the main database blade, you have a notification option, and you can see here, by the way, you can also see the performance recommendation, but you can see here the security the alerts. So you can see that I have 8 alerts for my database, 4 of them are new. So I will click on that. As you can see, I have several threats on my database. In some cases, some of these issues are related. So you can see the brute force attack, high number of failed login using different credential. But you can see also that someone was logging to my database from suspicious application, unfamiliar principal. And another interesting one, someone is logged on to my database from an unusual location. So I will dive into this alert, open it, so you can see similar information that appears in the email, the threat itself. But as you saw also in the vulnerability assessment, we are providing you a very clear investigation and remediation steps. In this case, someone has accessed my database from the United States. Again, I don't know if you remember, but France is from the UK, so it's very strange that someone is accessing his database from the United States. Maybe it's an attacker, maybe it's me. So the first thing that I ask myself when I get this alert is who did it and what did he do? So what we provide here, we provide you a link to investigate it, which will open your audit log around the time of the alert. So it's like opening a window in your audit log and shows you exactly what this user has done. So I can see that this user just failed to log in, he didn't do anything. But in many cases, it can help me to determine maybe it was some kind of a maintenance, maybe it was a real threat. In addition, I told you that someone is accessing my database from an unusual location. So how did he do it? So threat detection recommends me to check my firewall and lock down my firewall. And again, it provides me a clear remediation link that opens my firewall. And now we can see I have 3 rules on my firewall. The first one seems very practical. Again, France enabled access to his database only from New Orbit headquarters, the IP that belongs to New Orbit headquarters. Another IP, again, I need to check it if it's you or some of your employees. But this is very strange. Someone has added a new rule to the firewall, which allow basically every IP in the world to access this database. This is wrong, this is risky, and basically I should remove this rule and mitigate potential threats in the future. Okay, so now I will head it back to France. We'd like to share with you how New Orbit is benefiting from these intelligent capabilities on a daily basis. So, France.
Thank you, Ron. So, if I was back in the UK, this is when I apologize for keeping you from the pub. I don't quite know what the equivalent is over here, but apologies anyway. As Ron was saying, we've been using a lot of these features for quite a while. Some of these have only been announced here today or yesterday, but we've been using them in preview. So I just wanted to give you some actual real-life stories of how they've actually worked out for us. So as I mentioned, first on performance, I need to keep my systems running fast all the time. I think of auto-tuning and intelligent insights as my DBA in a box or as my little helpers, a bit like Santa's little helpers. They just sat there all the time looking after my databases for me. And I don't have a DBA, by the way. I should probably mention that. Despite having all these databases, I don't have a DBA working for me. That might be foolhardy, but it works for me. Now, it's hard enough when you have one database, one system that you've got to look after, but I look after more than a dozen systems and hundreds of databases for different clients, different systems, different databases, and I cannot keep on top of them manually. I need my little helpers to do the work for me. Now, a couple of real stories about the performance thing. The first one is the kind of big, scary, canonical story that people will always talk to you about when they're explaining why these features are really great. So we had a system, periodically, quite a large system, a lot of users, big client. Periodically, it would just stop. It would just almost crash. It would slow down, so it was unbearable. And we just could not reproduce this problem for love nor money. We knew it was the database. Something was hitting the database and just, completely exhausting all the resources. But beyond that, we were clueless. So we got an early version of Intelligent Insights, worked with Microsoft on it, and we figured out there was just one query that on its own would take down the database. It was a read query that created over 1 billion writes. Thank you, Entity Framework. But Intelligent Insights found it. We fixed it by swapping 2 lines around in our code and had a fix in production 2 hours later. Not only did that make my users happy, it also saved me a fair amount of money on my next Azure bill. So I was quite happy. But the second story is one we have on quite a regular basis, and the one I think is actually much more important, because those big scary things, they don't actually happen all that often. The thing that happens to us quite regularly is that systems grow, usage patterns change, okay? I put my system into production, it's running fine, users are happy, there's 10,000 rows in the database, 6 months later there's 1 million rows, and it's not working anymore, I need some new indexes. That's, to be honest, that's the thing that's happening again and again and again in my business. And that's where the real value of things like the auto-tuning really comes in, because it just fixes it for me. I will admit, it took me a while to start really trusting it. I like control. I want to keep track of my indexes, and it was great. Azure would tell me that, oh, maybe you should do this index, and I'd go back to my source code and set it up in the migration scripts and manage it. You know what? These days, I'm a lot more lazy than that. We focus on the database structure. We put in the most obvious indexes, and then, we shove it up there to Azure and let it run. And auto-tuning figures out what it needs to do. I might be able to get another 5 pence out of it, another few percent if I hand tune it, but it's so much cheaper not to worry about it. Okay? It's just pragmatism. If you're a hardcore DBA person, then that's probably not how you want to live your life. I just want to get software out there. It works for me. On the security side, if anybody had told me that part of my job would be to sit with auditors and talk about ISO 27001 and GDPR and fill in pages and pages of spreadsheets and stuff. I think I would have chosen another career, but I am where I am. So what vulnerability assessment does for me is it helps me find out where I need to take action. And I actually do show it to auditors. Ron mentioned that. I do show it to the auditors when they come in. And it tells me, these are the key things, it tells me that I need to audit the access to the database so I can see when my developers and my support people are looking at my databases. Okay? And that, Azure SQL gives me that, and vulnerability assessment tells me to switch it on. And that's really important if you're looking at things like ISO 27001 and data loss protection and that kind of stuff, data loss prevention, sorry. It tells me that I need to encrypt my data, switch on TDE, you know, the encryption at rest stuff. Again, ISO 27001, absolutely. GDPR, if you're familiar with it, if you're from Europe, you've got to worry about it. And if you don't have TDE on, basically you're toast if you have a data breach. Then you get a £10 million fine, basically. It's that, I'm not joking, by the way, that's actually true kind of thing. Maybe exaggerating slightly, but it's pretty much true. Trust me on that one. Finally, the baseline. As Ron was mentioning, the system will keep track of what my security settings for the database was, so I know if something has changed. Again, if anybody of you had to work with any kind of quality process system, any security process, you know that's key, okay? So, sorry, you will get to the pub very soon, I promise. The key thing to remember is developers are human too, and humans make mistakes. You know, we do everything we can to stop them from making mistakes. I do. We use Entity Framework. I've actually had one of the hardcore developers from Microsoft tell me that I was an idiot for using Entity Framework, because you can get another 2% performance out by not using it. My view is it stops them from making stupid security mistakes, so I'm happy to pay that 2% performance penalty. But even, I don't know if you know this, how many use Entity Framework? Yeah? Do you know you can still do SQL injection attacks, even with Entity Framework? All you got to do is stick a store procedure in there and have somebody who thinks a string concatenation is a great idea. And hands up, we had that happen to us on Bank BI. One of the developers did exactly that. He put a SQL injection vulnerability into a store procedure. This is a real story. Luckily, it wasn't in an area that could actually be maliciously abused, but still, threat detection picked it up. We had the email. All panicked, they ran around a little bit shouting at each other and saying what's going on in our live system. But then we clicked on the link, took us to the portal, showed us the query, tracked it down in the source code, and about 2 hours later, the fix was in production. Now that makes me sleep at night. Much better, right? Now, almost done, I promise. I just want to say at the end of the thing, Ron mentioned you get these emails when somebody's accessing a database from somewhere else. Now that happens fairly frequently to us. A developer will work from home or they'll go on holiday and they'll log in and do something. And it's quite practical, but it also gives me this nice warm fuzzy feeling, because it might be sentimental almost, but it reminds me that my little helper is sitting there looking at my system, and when something is different, it sends me an email. And that just makes me happy. So. I think, was that it? Sorry. Let me just check that. Okay. Is that it? Is that your slide?
Yeah.
Thank you. Sorry, I get myself confused there. I just wanted to say, I'll stop waffling on now, promise. But if anybody wants to talk to me about any of this stuff, I'm always happy to chat about Azure stuff. So look at my speaker pro, send me a tweet or an email or something like that, and happy to talk. Thank you very much. Thank you, Ron.
Thank you, Franz. So to summarize, okay, let me summarize. So as you saw in this session, Azure SQL Database provides you a powerful built-in intelligent capabilities. It provides you performance intelligence that help you to speed up your application according to your database workload. It provides you security intelligence, which help you to secure your data and protect and detect threats as it occurs. As you saw in our demos, it's super to enable. You just need to go to the Azure portal, use REST API or PowerShell, and you get this feature on. You don't need to change anything on your application code in order to benefit from this feature. Once you set it on, you are getting actionable recommendation and alerts, which help you to tune and secure your database. You also saw how New Orbit is choosing Azure SQL Database and benefiting from its intelligent capabilities on a daily basis. New Orbit is spending much less time in tuning and securing the database and put more focus on developing their application and evolving the business. A lot of what you saw today may seem or feel like the future, but all these capabilities are available for you today to use. So we encourage you to choose Azure SQL Database as your primary database technology, which can make a major difference for your application and for your business. So thank you all. We are now opening for questions, if you have any question for each one of us. Yeah, go ahead. You have a mic. I was told to ask you to go to the mic.
It's because of the recordings.
Hello?
Thank you.
Superstar.
This is
So what I want to ask is, your automatic deletion, what criteria is it based on? I mean, is there a certain amount of time before it recognizes as an unused index?
Yeah. There are two criteria. One is that the index is exactly the same duplicate. If you have two same indexes, one will get...
That's understandable, yeah. But I'm talking about the unused ones.
The second is that the index is not used for 3 months.
3 months,
Yeah.
okay.
That's the criteria we went with.
It's just we've had a client where it was unused for 3 weeks, we deleted it, and then month-end reports, everything was chaos. So,
Yeah.
okay, cool.
Exactly.
Thanks very much, 3 months.
Yeah.
Okay.
One question is this available, say, if you're running a platform on Azure to monitor your SQL database, or even if you have a mixed environment called a hybrid? Are they available there?
The log analytics piece, right? The monitoring.
The monitoring, yes.
This Azure SQL Analytics that we saw is scoped to Azure SQL databases, but log analytics is such that you can push any logs into it. Currently, you don't have out-of-the-box solution for monitoring databases on-prem, for example, but you could push the logs and get all of the logs in the same place. Idea is that log analytics will expand to cover that case as well, but currently there is no out-of-the-box solution.
Okay. For security, by the way, vulnerability assessment is available also for SQL on-prem using the next SQL Management Studio. So if you will download the latest SQL Management Studio, you will be able to run it against SQL VM or SQL on-prem. The threat detection, unfortunately, are currently supported only for the cloud.
Okay. All right.
Yeah.
Thank you.
I may have missed it, but when are all these features available?
Now.
Everything available today, now. You can go to the Azure portal now and use it.
Bye.
Hi, how are you? Is there any, for example, with the alerts for the threat detection, is there any future to automate what to do based on a certain threat, right? Rather than have to manually monitor it, can I say after 50 attempts, just shut the server down?
This is a good point. Well, do consider it as part of the roadmap. In many of the cases, these anomalies may be legitimate. So it's very risky to do automatic stuff unless you are sure for 100% because it might impact your business. But we do have a plan to smooth investigation and consider some of automatic action. But again, it needs to be very careful because if we make mistakes, then we can damage your business.
Right, because I can understand. I worked in financial services as well, and believe me, they'd rather just shut it down.
Yeah. Thank you.
One thing I would add for that question is when the data lands into log analytics, you can actually define an alert that will be fired, and you can define an automated action. So the things we saw in log analytics, let's say you have huge number of errors immediately. You can define an alert that says, if number of errors larger than 10, do this action. Action can be send me an email, but it can also be call a webhook or execute a PowerShell script. So you could automate with some of the aspects there.
Thank you all.
Thank you all.